I don't want no failure.
Failure is allowed. What do you mean?
You're dead. You know what the old saying goes, the first you don't succeed, quit. So, what? Okay, here we go. Let's look at the first one. Guys, need your attention, please. There's some good and some bad up here, so let's look at it both. All right. Mass of 2 moles of copper. We're starting with 2 moles of copper. Number, unit, label. You bring down the unit, the label, moles of copper, and you're converting to grams of copper. 63.54. If you don't want to round, if you want to round, great. If you don't want to round, that's fine too. Grams of copper. Multiply across, because our goal was mass of copper. We have mass of copper. We do our math. 2 by 63, 127 grams of copper is our final answer. Okay. Give me a thumbs up. You can see how number 1 went good. All right. Number 2. Mass of 3.4 moles of O2. So, first of all, how many things are in this box? 2. How many should be in here?
3.
What's missing?
O2.
O2. But I just want to put numbers. No. Because you're going to bring it to me. You're going to be like, I don't understand where I went wrong. And I'm going to be like, neither did I. I don't know what these numbers mean. So 3.4 moles of O2. 1 mole of O2 is 32 grams of O2. There is nothing but sulfur that is 32 grams. You're like, okay, 32 grams. It must be sulfur. No, it's O2. You need to say O2. Doing the math, once you have your unit, mass of O2, 3.4 by 32 gives you 109, 108 grams per mole, right? No. The last unit is grams O2. So your answer should be grams O2. Okay. Your answer's unit and label should be lifted off whatever the last upper box is. Okay. Give me a thumbs up if you can see how number 2 worked. Okay. Put your hand up and raise it around if you have any questions. You're like, I don't know. Help me. Okay. Next, flipping it around, we're starting with grams and we're going to moles. 89 grams of CO2. 1, 2, 3 things. Grams of CO2 comes down. Moles of CO2 goes over. There are 40. Don't talk when the grown-up is talking. There are 44 grams of O2 in 1 mole. Divide across because we have moles of O2 or CO2, which we're looking for. Grams CO2, grams CO2, grams CO2. About 2 moles of CO2. Don't need that thing right there. Okay? Give me a thumbs up to go with number 3. Numero 4. Okay. Now, luckily someone made this mistake. You never start with a conversion. Never start with a conversion. Because how many boxes is a conversion? 2. 1 up top and 1 down below. This is 187 grams. It's missing its stuff down here. You do not start with a conversion. This should be 122 grams of copper 2 nitrate. If there's grams of copper 2 nitrate down here, grams of CuNO3 quantity 2, and we're going to convert to moles of CuNO3 quantity 2. In every 1 mole of copper 2 nitrate, there's 188 grams. That's what we should have seen. Doing the math. What is the math, by the way? What's the answer? 0.65? 0.65, and the answer will be mole of copper 2 nitrate. Okay. How are we doing? Give me a thumbs up if you're with me, and put your hand up and wave it around if you need help. All right. One more thing to talk about in the last 7 minutes we have. Let's say you get home, guys, you get home when you're hungry and you want to make a sandwich.
Wait, what?
And
Okay.
because you don't have 2 Teslas, you have to make it yourself. There's no butler that's going to make it for you. And you open your fridge and you notice there's slices of cheese and there's big, thin, succulent pieces of chicken breast. And you're like, awesome, I'll make it a chicken sandwich. So you need 1 piece of chicken, 1 piece of cheese, and 2 pieces of bread. Right? That's a ratio. 1 chicken, 1 cheese, 2 bread. And your neighbor says, you're like pulling up, and you're like, oh, your neighbor's like, hey, I'm really hungry. Can I come over and play PlayStation and eat sandwiches? Great. Now I'm going to need 2 pieces of chicken, 2 pieces of cheese, and how much bread? 4. That's a ratio. Okay? Your basic ratio, you can play with the multiple all you want, but there's a ratio. And then your other neighbor comes in, and he's not your favorite neighbor, and you're like, can we play too? Sure. And you open the fridge, and there's only 2 pieces of chicken. There's plenty of cheese, there's plenty of bread, but there's only 2 pieces of chicken. And you're like, sorry, we can't make our sandwich because our chicken is limiting how many sandwiches we can make. Chemistry works the same way. Chemistry has what are called limiting reactants.
Minecraft. Oh my gosh, dude. That is a diamond pickaxe. Let's watch out.
Okay? So in chemistry, there are things that are limiting. They are the things that get used up first. Imagine, so you've all played Minecraft. If you haven't, you should play it because it's what all the 8-year-olds are playing now.
You know what? It taught me how to build, alright?
Yeah. So
It's a really
to make a, guys, to make your iron pickaxe, it takes 3 iron ingots and 2 wood sticks. It takes 3 iron ingots and 2 wood sticks to make an iron pickaxe. So we might write the formula like this: 3 iron ingots plus 2 wood sticks equals 1 pickaxe. Make sense? So 3 iron ingots plus 2 wood sticks makes 1 pickaxe. If you have 12 iron ingots and 10 wood sticks, how many pickaxes can you make?
4.
Most of you realize right away it's 4, because if I have 12 iron ingots, I have a multiple of iron ingots, I can make 4. 12 over 3 is 4. And if I'm going to make 4 and 4, I'm going to need 8 wood sticks. Most of you realize, if you thought in your head, if I made 5 pickaxes from 10 wood sticks, I don't have enough iron ingots to make all 5. So what we would call, the iron ingots we would call our limiting reactant. It determines how much we make, and it gets entirely used up. The limiting reactant gets entirely used up and determines how much product we can make. The thing that is not limiting is called excess. The excess reactant is what's left over. In our little Minecraft example, what is excess? The wood sticks. And when we're all done with our wood sticks, there's 2 in excess. 2 in, well, that's going to be there for the other time. There's 2 in excess. 2 wood sticks in excess. So you'll have something when you get your diamond, you can make your diamond pickaxe. Okay, where does all this stuff come from? It comes from the mole ratio. And we're going to investigate this idea about limiting reactant and mole ratio, dealing with moles. We're going to investigate it tomorrow and Wednesday. And then Thursday and Friday, we will pivot towards grams, which is the meat and potatoes of stoichiometry. But today, or tomorrow and Wednesday, we're really going to deal with mole ratios and limiting reactant. The mole ratio comes from the balanced chemical equation. In this case, 3 iron ingots to 2 wood sticks to 1 pickaxe. That's our mole ratio.
At least it's not a sword.
Oh, it can be. It might be tomorrow.
Oh, it might be a shot.
Yeah. It might be some diamond armor.
No, that takes too much.
Okay. All right. Any questions? Okay. If there are no questions, this is a good place to end.
Yes.
So we'll just end right here.
Question.
Questions?